Hey, everybody. Let me get some water. Okay.
How's your weekend, Dr. Chai?
Hey, Eddie. It was good. Yeah, it was my mom's birthday yesterday, so we took her out to dinner. So that was nice.
Nice. Where'd you guys go?
We went to this Thai restaurant called Thai Nakorn. I actually thought I didn't know that they relocated because when I was growing up, like they had a location close to Knott's Berry Farm, and I would go there a lot with my family. But the restaurant burned down, and I didn't think that they still existed. But apparently they moved to a different location, which is good because their food is really good. So it was nice.
What's it called?
Thai Nakorn.
Never heard of that.
Yeah, it's pretty good. If you like Thai food, then they're definitely one of the better ones.
Oh, interesting.
That's cool.
How about you guys? How's your weekend?
Not too bad. Just a bunch of housework.
Nice, nice.
Yeah, same. Just some light homework, gym, and then watching the game yesterday.
Nice,
Oh yeah,
nice.
that's right. Watching the game.
Yeah, they were good games.
Yeah, they were.
We were watching that in the restaurant. I feel bad because it was my mom's birthday, but me and my dad we were watching the TV for most of the night.
Oof.
Not paying attention to my mom, but she understands.
It was
I mean,
that good.
Yeah,
Yeah.
these playoff games were like really good this
Yeah,
season.
yeah.
I know they've always been fantastic.
So many overtimes, man. That's been insane.
Yeah, yeah.
Yeah.
It was the football game, Jiuhua. It was the Rams and 49ers yesterday.
Yeah, that Bengals win was crazy.
Oh yeah. That was one hell of a comeback.
I was following the score because I was running errands earlier that day, and I saw that the Chiefs were up 21-3. I was like, oh man, it's over. Patrick Mahomes is gonna close this out. But then I checked back later, I'm like, it's tied. I was like, wow, what happened?
And that pick at the end was crazy.
Yeah, yeah.
For today, do you recommend that we should probably have a MATLAB open? Or not?
Yeah. If you want to follow along, there's some examples, but I kind of talk through them just because there's kind of a lot to go over. But if you want to type in the code, then you can do that.
Yeah, why not?
Yeah, I don't have any like full examples until the very end. I ran this tutorial last Wednesday for a different class.
Mhm.
And we went over a little bit, and so I didn't really have that much time for the examples at the end. So a lot of it was just kind of me talking. But if you want to type in some of the code as I'm talking, then you can go and do that.
Yeah, sure thing.
Mhm. All right, it's 5:30, so let's go ahead and get started today. All right, good evening, everyone. How's everyone doing today?
Doing good.
Good, good. All right, so the plan for today is we're going to do a I call it a MATLAB review, but I think it's more like a MATLAB crash course. And so, just like we've been saying last week, this course is going to be pretty heavy on the MATLAB. And so I want to make sure that we go over it, just so that we're kind of prepared and we're all kind of on the same page. But with that said, there is going to be a lot of information today. I'm not sure exactly what everyone's bringing from like their past MATLAB experiences, like 205. I've yet to teach the class, even though I've requested it every semester. And so, maybe the way I do things, maybe the way I set things up might be a little bit different from how you've learned before. But the way I'm kind of teaching you things now or today is going to be good convention for going forward, because when you're writing computational programs, especially for computational heat transfer, it really helps kind of set things up a certain way, like set up your variables a certain way and to fill out matrices a certain way, just because it's just a lot kind of easier to work with. And so even if a lot of this is review for you, I would recommend that you look at and see how I've set things up and how I do things. And then let's try to use those moving forward, and where I see it, and kind of and just kind of inform just from my past times teaching this class, I did try to include some places where maybe you're used to doing like this, but for this class it'd be better to do it like this. Yeah. Great. All right. Okay, and so other announcements. The first homework is posted, and so oh, and by the way, thank you for everyone that sent me introduction emails over the weekend. I think I had 100% participation from this class, so thank you everyone for getting it on time and for being prompt with that. So I really appreciate that. The first real homework is posted though, and so that is you can find that on the Canvas site. And a lot of that homework is going to be just kind of based on the review that we did last Wednesday. And just kind of practicing on the MATLAB skills that we're going to practice, that we're going to learn today. Okay, and so I believe I'm having that due next Wednesday, and so definitely make sure you take a look. Especially if you're not that confident in MATLAB, it definitely helps to look at it sooner than later. And if you need help, just stop by office hours or just let me know, and and I can help you out as best I can. Okay. All right, and so I think that's it for the announcements. And so are there any questions I can answer before we get started? Okay, all right, so let's go ahead and get rolling. Okay, and so just as an introduction first, let's talk just briefly about what it means, or what computational engineering means. So remember, the title of this course is computational heat transfer, and a big part of that name is computational. And so whenever you talk about any kind of computational engineering, basically what you're referring to is the use of a computer to augment your engineering work, right? And the big advantage that computers have over what humans can do is that they're much better and much faster at performing arithmetic calculations. Okay. But this all comes with a caveat, and that caveat is that you have to be able to utilize the computer to its full potential. And the way that the way that we as humans, we communicate tasks to the computer is through coding, right? And so whether it be MATLAB coding, Python coding, C++ coding, code, you can almost think of it as like the language of the computer. And so a computer, even though it's really powerful, it's not sophisticated enough yet to really understand how humans are thinking and how to solve engineering problems. And so we have to put our problems in a way that a computer can understand so that they can help us. And a coding language and a coding style is how we do that. Okay. And so some of the coding languages that are used specifically for engineers are languages like MATLAB, like Python, C++. You might have heard of Fortran. So Fortran is a much older language that honestly nowadays probably people laugh at you if you still use it. But I actually do know quite a few applications, and a lot of actually really big companies still use Fortran too. So it's not as much of a joke as people make it out to be. And there's another up and coming language called Julia. And so Julia is doing a lot of really cool stuff. And so I actually think that if probably in a few years, Julia might be much more mainstream than it is right now. I
Have you
think the
tried it?
I
Have
have
you
tried it.
tried Julia?
I have, yeah. It's nice. I think the issue with Julia is that their marketing team is probably some of the most obnoxious people I've ever met, and so they're like I think the stereotype that that CrossFit people have and vegan people have of like really showing off that, like, oh, I use Julia and I'm cooler than everybody else. Like that's kind of their marketing approach right now, and it's really obnoxious. And so I think
That's
that's why
true.
people don't use Julia as much. But just from a technical perspective, there is a lot of really cool things about it. But I just think they need better marketing. Um, but that's not hating on CrossFit or vegan people. Actually, my sister's vegan, and she's super chill about it. So I just use that as an example, just because I think it's a stereotype. But most vegans I know are really cool. I think there's a reason they named it that, but I'm not sure. But yeah, it is cool. It's just I think it's going to take a while before people adopt it. But anyway, whatever language that you use, they're all kind of can give you the same capabilities, because with these coding languages, it basically allows you to run simulations by rapidly solving differential equations, which is really powerful. All right, so what is MATLAB, and why do we use it? So MATLAB is a program that's designed specifically for performing mathematical calculations. It's really designed with ease of use and convenience in mind, and so there's its interface is really user friendly. And a lot of its coding conventions really kind of help you out in without you having to worry about a lot of the computer sciencey stuff. And so it has widespread use, and so it has a lot of use in education, research, and a lot of engineering applications. It is relatively slow, and so it's definitely not the fastest language, mostly just because of all the conveniences that it gives you. And so you'll very rarely see big codes written in MATLAB. But it is great for quick prototyping and for classes like like what we're going to do for this one. And so why are we using MATLAB in this course? Because it is very commonly taught. A lot of people take a lot of universities they have at least an introductory level course in MATLAB. There's a lot of built-in functions that are really great, and they really kind of simplify a lot of the coding for you, so you can focus a lot on the theory and the fundamentals without really getting bogged down in the details. The error messaging is really good. So, a lot of times MATLAB will tell you pretty specifically what's wrong, and you can kind of debug from that. There's a lot of really nice plotting capabilities, and so you can plot things really easily, and it has a really strong online community as well. Yeah, and it's relatively cheap. Okay, and so now that we have an introduction of what computational engineering is and why we use MATLAB, let's just jump right into the details. And so I would say kind of the first skill or the first piece of knowledge that you should have whenever you're learning a new language, programming language, is to define a variable. Okay, and so this is really the first step for any kind of scientific program, because variables are extremely useful entities in programming, because what they are basically are labeled entries. And so by labeled, all I mean is that they have a name. And these are entries that the computer program uses to store information to be referenced and manipulated later. Okay, and so the key here is to be able to store information. Okay, because anytime you're running a computer program, you're either specifying parameters, or you're generating data, or you're doing calculations, and you need to be able to store that information somewhere so that you can refer to it later. And that's what variables are used for. Okay. And there's several types of variables that you can have depending on the format of your data. And so I have three kind of broad categories here. So we have a scalar variable, where a scalar basically just stores a single variable. And so one example I have is down here. Okay. And so if you want to store a single number like the number 6 or the number 7 and stuff that into a variable, you can do that with a scalar. Okay. There's also vectors. So vectors are a way for you to store a collection of values. And the way that they're organized is in a list. And so you have basically just a list of numbers, just like that. And so if you have a variables that are organized like that, or data that's organized like that, we say that it's stored in a vector. Okay. A matrix is another form of data storage. And just like the vector, it stores a collection of values. It's just the way that it's organized is a little bit different. And so instead of a a list like this, right? What you store it in is as a 2D construct, and so there's both kind of height and width to it, right? And so I think everyone's seen a matrix before, and so it looks something like this, right? And so just like a vector, you have multiple values being stored at the same time. It's just that the way that you organize it and the way that you reference it is a little bit different. Okay. And the nice thing about MATLAB is that MATLAB basically gives you almost the same syntax for everything. So whatever kind of format that you want, you can use MATLAB to create those kinds of data types and variables. Okay. All right. And so when you define a variable, and so when you create a new one in a program, there's basically two things that you need. And so there's you need to give it a name, and you also have to specify its value. And the way that you connect these two is with the equal sign operator. And so the equal sign is a specialized character in most programming languages. And a lot of times what it does is it allows you to assign a value to a name or assign a value to a variable. Okay. And so in this example right here, I'm just defining a variable. And so I have this variable called scalar example, and I'm going to assign a value of 6 to it. Okay. And so you can see I've kind of broken it down to here for you. So here I have the name of the variable, which is on the left-hand side of the equal sign. Here I have the value that I'm going to stuff inside. Okay. And then by putting this equal sign here, what we're saying is that, we have this name of the variable, and we're going to take this value 6 and stuff it inside there. Right. And so from here on forward, whenever we refer to the scalar example, it's going to have the value of 6. Okay. Right. So defining variables is kind of the first step that you do whenever you're running a new program, and it's really useful for a lot of things that we're going to do. Okay. Any questions on this? All right. Okay. And so now that we have this variable called scalar example, we can now use this variable later in our code to perform arithmetic operations. Okay. And so let's have this example here. Right? And so let's say that we define a new variable called scalar operation, and its value is going to be a combination of the previous variable that we had. Right. And so we know from the previous page that scalar example has a value of 6. Right. And so basically every time we see scalar example, we can just plug in a 6 there. Right. And so this new variable that we have called scalar operation, we can see that it's equal to 3 times 6 plus 6, right? And so 3 times 6 is 18, right? Plus 6, this is going to be equal to 24, right? And so this variable here, scalar operation, which was created as a using a formula from the previous variable, its value is now going to be 24. And so that's how we use scalars, and that's how we use operations on scalars. Right? And so we can define vectors in the same way, using the same equal sign. The only thing that's going to be different is going to be on the right-hand side of the equals. Right? And so instead of assigning a single variable, instead of assigning a single value, what we can do is we can assign a list of values instead. Right? And so you can see here we have a variable called vector example, and then inside that vector example, we're going to store a list of 3 values here. So we have a 7, we have a 1, and we have a 4. Right? So that gets stuffed inside there. Right? So now whenever we refer to vector example later in the code, then we're going to have this vector 714. Right? And we can also perform operations on these vector variables as well. So we can do a vector addition, which is what I'm showing you here. And so we can say that vector operation is equal to vector example plus 417. Okay. Since we just defined vector example here to be 7, 1, 4, we can have 7, 1, 4, okay? And then we just perform this vector addition. And so, we know that when we add vectors together, we just add the entries that's in the same location. And so we're going to add the first entries here. So we have 7 plus 4. So that's going to be 11, okay? Next, we have 1 plus 1 because both of those are in the second slot. And so that's going to be 2. And then finally, we have 4 plus 7. That's in the third spot. And so that's going to be 11. Okay, and so that's the result of this code right here. Okay, and so vector, you can store vectors and variables, and you can operate them in exactly the same way as a scalar. You just have to make sure that everything that you're operating on is also a vector as well. Okay. Any questions on this? Okay. All right. And so in addition to the classical way of defining variables with the equal sign and directly specifying the values, you can also use some special functions as well, right? And this is really useful because a lot of times we want to create data structures, or we want to create vectors, or we want to create matrices that have a certain structure. And instead of doing it kind of manually, we can use these functions that kind of help us out to create it a lot more easily. Okay, and so the first special function that I'll show you is one called linspace. Okay, and so what that stands for is basically linear space, right? And so what this does, it creates a vector with a specified starting value, a specified ending value, and a variable that'll take in the number of entries. Okay, and so in this example that I'm giving you here, I'm basically saying that I want to create a vector. I want to create a vector that starts at 0, right? And so the first entry in the vector is going to be 0. It's going to end at 10, and so the last entry in the vector is going to be 10, and I want it to have 5 different entries. Okay, and so the length of the vector is going to be 5, right? And so what MATLAB does is that it takes this information and says that, all right, here is a vector that has 5 entries, right? Just like you specified. The first entry is 0, the last entry is 10, and then everything else here is evenly spaced with each other. Okay, and so you can see here we go from 0 to 2.5 to 5 to 7.5, and then from 7.5 to 10. Okay, and so the gap in between each of these terms is 2.5, right? And so linspace basically helps you do that. And so linspace is a function where if you want to create a vector that has a list of numbers that counts up regularly, you can use linspace to help you out, and that saves you a bunch of code and work to do so. Okay, and so again, the way that you use linspace is that you have to provide three arguments here, right? And so you use the word use the command linspace, and then use an open parentheses, and you add 3 numbers. Okay, and so the first number is the first entry, the second number is the last entry in the vector, and the third entry here for the function is how many values that you want in your vector. All right, and so that's linspace. And so the next special function that I want to show you is zeros. And so zeros is something that we'll use a lot in this class because it's really useful. And all it does is that it creates a vector or matrix of a specified size, but all of the entries are 0. Okay. And so let's say that we want to create a vector that has 100 entries. Okay. So it's a really, really long vector, and we want all of them to be zeros. And so we can say that, looks something like this, right? All the way down to the 100th entry. Okay. And so it's a 100 long vector with zeros. Okay. And so, this is really useful because if we were to do this kind of the previous way where we assign each, we type out each one individually, we'd be sitting there at the computer for a long time because, we have to type out 100 zeros. So with 0, 0, 0, 0, 0, 0, 0, 0, 0, all the way until you reach 100, which is, not practical because, I think most people will lose count, or, it'll take a bunch of space in your code, and it's not really a practical thing to do. And so instead, you can use the zeros function to say that, basically give me an empty vector, give me an empty matrix, and then we can fill it in. We can fill it in later, which is typically what we do. Okay, so this zeros function is really useful because for a lot of the algorithms that we're going to talk about in this class, the assumption is that you start out with an empty vector or an empty matrix, and so to be able to create that in one line like this in MATLAB is really, really useful and really, really convenient. Any questions on this? Okay. All right. And so once a variable is defined, you can actually manipulate its value. And so, and this happens a lot. And so after you create a variable, that doesn't mean that the value of that variable is stuck, forever. Okay. And so what this basically means is that we can use the same name that we used before, but change the value that the name represents. Okay. And the way we do this is with an equal sign operator, just like before. Right? And so if you remember the scalar example here, right? It was a variable. It was a variable whose value was 6, right? And so maybe we used 6 for that part of the code, and we used it, and it was good. Okay. But later on in the code, maybe we want to change the value of scalar example to 9. Right? And that's perfectly fine. And so, at this point in the code, we can say that, all right, we're done using 6, And so now we're ready to change this value to 9. Okay. And so now that we've changed the the value of the of that variable, we can then go ahead and use that in other parts of our code, right? And so here's an example. And so let's say that we created a variable with the value of 7, right? And so we can say that we've created a new variable called new variable, okay, and set it equal to 7. And then we can create another variable called whodis, and then we'll set that value equal to 2, right? But then, let's say that we get to this part of the code and we say that, all right, I want to change the value of new variable from 7 to something else, right? And in the end, actually, I think I kept this at 7 because if you plug in 2 for here, you get 7. But but let's say that you wanted to change to something else, right? And so what you can say is that, on this line, what we're saying is we're reassigning the value of new variable, and we're setting it equal to this formula right here. So we can say that whodis is or new variable, excuse me, is equal to whodis plus 5/2 times whodis, right? And so since whodis is 2, we can just plug in 2 for all of these things. Okay. And then what we get here in the end is actually still 7 because these 2's are going to cancel out, and we have 2 plus 5, which is 7. Right. But instead, if we change the value of this variable to like 6, right? This would be 2 plus 6 is equal to 8. Okay. And so this is totally fine. And so you can use the exact same variable name, in different contexts, as long as you kind of know, when you're updating it and what the updated value is. Okay. All right. And so that's how we can manipulate variables in a program. Another useful thing that we can have is we can also update the value of a particular variable. Okay. And so this is something we're actually going to be using a lot in this class too. And so this is what I like to call update notation. Okay. It's basically when we take the value of a variable and we want to add something to it, or we want to subtract something from it. Okay. And so, this particular syntax, I think, might be kind of confusing to some people because you have whodis on both sides of the equal sign, right? But that's totally fine because, on the right side of whenever you see the name of the variable on the right side, it's basically taking the value of that variable from before in that code, okay? And so you can kind of, almost read this line of code as a sentence, right? And so we can basically say that the new value of whodis is equal to the old value of whodis. Remember, whodis has a value of 2, right? So the old value here is 2, okay? And then to that, we're going to add plus 9, right? And so we can say that the new value of whodis is equal to 2 plus 9, which is 11, okay? And that's totally fine, right? Because I think people kind of get nervous when they see a variable on both sides of the equal sign. Just know that whenever you see something on the right, then it's going to take on the old value, before anything has happened. Okay. All right. Any questions on this? Okay. Definitely get used to update notation, and and I'll give you some practice with it as well because it's it's really it's a really useful thing, especially when there's a lot of variables that need updating in these kinds of codes. Okay. All right. And so how are variables used? And so this is actually a very broad topic that would take a very long time to discuss. But I like to categorize it in kind of two different categories. Okay. And so the first category of variables that can be used is to store basically parameter values, right? And so if we're talking like scientific codes, these are things like material properties, things like geometrical parameters, like the length or the area or the volume, right? And so with these kinds of usage, and I like to call these parameters, right? And so when you use a variable to represent a parameter, oftentimes these values do not change. So they basically are assigned one value, and then that value is kept, throughout the entire program. Okay, but these values are often referenced, later on when you're performing calculations, right? So let's do a very quick example. And so let's say that we're writing a program to compute the area of the circle, and so we can define a variable up here called radius. Okay, and so that's equal to 4. And so once we define that value for the parameter, usually that doesn't change, right? And so, from everywhere in the code, the radius is always going to be equal to 4. And so we can say that maybe later on in the code, we want to compute the area of the circle, and we just plug in the formula for that. So we said that area is equal to pi times radius, okay? And that radius, remember, is a parameter whose value does not change, okay? And so the format that you'll see me use for a lot of the codes that I give you and a lot of the codes that I ask you to write is I have kind of a top section of the code, right? And so you can imagine that this is your text editor for MATLAB, right? Okay. And so the top section of the code right here, this is usually where I define all the parameters. Okay. Okay. And so things like those material properties, those things like the geometrical parameters. Later on, we'll discuss things like how many elements do we want in the mesh, right? Or how many grid points. And so this is where those parameters usually go. And so usually I'll separate out this section, and so I'll create kind of like a blockade of like comments here, okay? And so just know that usually when you specify parameters above that, then their value shouldn't change anywhere else in the program. And that's pretty standard, I think. For a lot of especially heavy programs, they have sections in their code where they define a bunch of parameters, they define a bunch of stuff, and and the users are not supposed to change that at all. Okay. All right. Another important use for variables is to store values. Okay. So remember, like I talked about before, that when we're using computers to solve engineering problems, normally there's going to be a lot of calculations that take place. Right, and so you're going to need to be able to store those values in variables so that you can perform other calculations. Okay, but unlike the parameters, which are given above, these values are either constantly being changed, or they're being changed a lot, and so or they're being updated, right? And that's all part of the algorithm. Okay. And so that's kind of the other category of variables that are out there. And so there's lots of different ways you can describe variables, but I think these two, the distinction between these two is useful, especially kind of when you're first getting started out writing scientific programs. All right, and so before we move on to the next page, I want to give you a piece of advice. And so it really helps you out a lot if you give descriptive names for your variables. Okay. And so the tempting thing, especially for if you want to replicate, like ace programmers that are typing really fast, the really tempting thing is to use variable names that are very short. And so to use a variable name like X or Y, right? And so I see this all the time when people are programming. They say like X is equal to 9, right? Right. And then later on in the code, they might have a mistake where they have a formula that includes X, but they have no idea what X represents, right? And so they have line of code that uses X, and they're like, what the fuck did X mean? And it's really hard, because then you have to scroll all the way back up to the program and say like X, you have to find where you define X. It's like X equal to 9. Like, okay, now I know what X is. And you go back down and you try to debug it, and you're not really sure what's happening. And it's I think that's the part which frustrates people a lot is, I think people generally like typing. They like typing the code, but debugging the code is the part that most people hate. And so if you use short variable names, you're really just kind of shooting yourself in the foot, and it makes it just that much harder to debug, because you're looking at these complicated lines of code with that take into account like 6 or 7 different variables, and if they all have crappy names like X, like Y, like Z, like A, it's going to be impossible to figure out what's going on. And so give good names for your variables. And so a good example of this is here, right, where we define this variable called radius. And so we know exactly what the radius is, right? And so imagine that this is on line 1200, right? So really far down your code, we know exactly what we're doing here, because we're taking pi times the radius, and that makes a lot of sense, because that's a formula that we recognize. And so if you can imagine that you use a variable name, even something reasonable, like you use R, right? So you say R is equal to 4, right? And so instead of pi times radius, you say pi times R times R, right? Maybe you don't know what that is, like you don't recognize that formula, and R, having a single variable named R here is not really doing you any favors, right? And so I know it takes more time. I know it takes, it makes your code look really long, and it takes longer to type, variable names that are words instead of letters. But trust me trust me, it saves you way more time in the long run, because when you're debugging your code, when you're trying to figure out what's going on, it just makes it that much easier to say, like, okay, I know what I was thinking here because I'm using this name, versus trying to figure out what's what the heck you were thinking yesterday or something like that. Okay. And of course, don't use long variable names just for the sake of it. And so if you write a name like this, yes, it's long, but it's also not very helpful, because you're cursing at the program and the program doesn't really know what's going on. And so use descriptive names, and it's only going to help you out in the long run. Okay. Although I am guilty of doing this in the past, especially when I'm upset with my programs. Okay. All right, any questions on this? Okay. All right. So now let's talk about matrices. And so matrices are really important for us, because they are they're synonymous with linear algebra, right? And we're going to be doing a lot of linear algebra in this class. Okay. And the main reason for that is that computers are really, really good at doing linear algebra, like absurdly good at doing linear algebra. And so because of that, the aim of most computational codes is to convert a, here I say a partial differential equation, but it could be, it could be any engineering problem. Is to take an engineering problem and then convert it into a system of linear equations, right? So that's basically the main goal. And so, if you're writing a code for finite elements, you're writing a code for finite differences, finite volumes, that is always the goal, is to get it, let's take this problem, let's get it into a system of linear equations so the computer can solve it. And the computer is really, really good at that. And so that's usually a good thing. Okay. And so in order to make use of this, we have to learn how to define matrices and use them effectively in our code. Okay. And so MATLAB actually gives you several different ways to specify a matrix or define a matrix. Okay. And so one way, and this is probably the way that you might have learned it in a previous class, is to manually specify every single entry in the matrix, and using square brackets and commas and semicolons to denote the different rows and columns. Okay. And so usually the convention is to list out a matrix row by row. Okay. And so if we want to create this matrix in the bottom here, where we have all ones on the first row, we have 999 on the second row, and then on the third row we have 468. We construct this matrix row by row. Okay, and so we say that our first row is going to be 1, 1, 1. Okay, we use a semicolon here to denote that we're going to the next line, and so we say 1, 1, 1, semicolon 9, 9, 9, semicolon 4, 6, 8. Okay. Right, and so that makes the following matrix. And so from this MATLAB can see that, all right, he wants a matrix where the first line is all ones, then the second line is all nines, and the third row is 4, 6, 8. Okay. And so this is probably, at least for me, I remember this is the first way that I learned how to make a matrix. But actually, for a lot of situations, this is actually not that useful, because it's a little bit rigid and it's a little bit constraining. Okay. And we'll talk about why on the next page. Okay. But before I get that, are there any questions on this? Okay. All right. And so the previous method is it can be compact, right? And so by compact, I mean that it takes up very little space in your code itself, right? So you can fit it all in one line, but you can really only use this method if you know all the matrix values beforehand, right? And so you're probably looking at that and saying, why wouldn't we know all the matrix entries beforehand? Well, a lot of the algorithms that we're going to be talking about, we actually build up the matrix, over the course of many calculations. And so you actually don't know, and for a lot of cases that we're going to be dealing with in this class, you actually don't know what the final matrix is going to look at until after you perform a bunch of computations. Okay. And for that reason, it's actually more convenient to define a matrix in a different way, right? And so the common way that we'll actually create matrices in this class is we're going to make use of the zeros function, right? So remember the zeros function from earlier today. What this does is that it creates an empty data structure where all the entries are zeros. Okay. And so, at the conclusion of this line right here, we're going to have a empty 3 by 3 matrix, right? And so we have 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay. And then from here, we're going to manually assign, each of the entries in the matrix kind of one by one, right? And so we can say that, we want the entry in the 1, 1 slot, which this stands for the first row and the first column, okay? And so we're going to set this entry equal to 1, okay? And this is how you refer to entries in a matrix. And so you go row, comma, column, right? And so you search the row first, and then you go to the column, right? And so in the next line here, we can say that we want the entry in the first row and the second column. We want this to also be 1, okay? And then similarly for the next line, we have 1, 3. And so the entry in the first row and the third column, okay, we want that to be 1, right? And then so on and so forth. So next we go to the second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, third row, third column. Okay. All right, and so this is a way that we can create a matrix and assign the values, using the zeros command, right? And so if you're looking at these two blocks of code, so this is kind of creating a matrix, kind of the direct way, whereas this is creating a matrix using the zeros example, or zeros of function, right? And so you're probably looking at this and you're wondering, why the heck would we ever do this, right? Because this is just so much typing and so much more work than just doing it, in one line, just like this, right? And so remember, a lot of times in this class, we're not going to know what the final matrix is going to look like, until we do a bunch of calculations. And so it doesn't make sense to, to try to create a matrix beforehand, when we don't know exactly what's going to be in it, right? And so with this method, you can create an empty matrix as kind of like a blank canvas. And then later on, you can perform calculations and assign values, that are, that they need to be, to get where they need to be within the matrix, okay? The other reason we use this method is that there's going to be a lot of zero entries in our matrices, okay? And our matrices are going to get a lot bigger than 3 by 3 as well, right? And so I kid you not. And so, we're going to have times in this class where our matrix is going to be like, probably 100,000 columns and 100,000 rows, right? Right. And so can you imagine, trying to create or assign a matrix like this? And so you're gonna have to write 100,000 by 100,000 entries. It's just not feasible, right? And so the way that we usually create these matrices is using for loops, which we'll talk about later, and then starting with the zeros matrix and filling in the values, as we go along. Okay. And in such big systems like this, actually, the vast majority of entries are still going to be 0, right? Which I find to be a fascinating thing about this theory is that you do all this work to do calculations, but most of your matrix is still going to be 0 at the end. That's just how the algorithms are designed. And so if you have kind of a vast majority of zeros and only a few non-zero entries, it doesn't really make sense to try to create this matrix beforehand. Where instead you can create just a blank canvas of zeros. All the non-zero entries, you can just add it to it, as you go along. And then everything else you can just leave alone because they're going to have all the values that they need.
Okay. I had a question about this. Does
Sure.
the update method work within matrices as well?
It does. Yes, that's a great question. And that's something that we're going to, I think I have a slide later that shows it as well. But that's something we're going to make use of quite a bit as well. And so, let's say that, we want to, I'll save it for later because I think I have a slide dedicated to it. But yeah, that is one of the main ways we're going to use the update. The update notation is within matrices. Okay. All right. Any other questions on this? Right. I know it's a lot of information today, and I know maybe for a lot of you this is the first time you're seeing MATLAB in a few years, and so I know not all of it's going to stick, just after the first time you hear it. And so, the way, I made a lot of effort to make this into a slide that you kind of go through. And so what I'm hoping for is that, not that you retain all of this at once, but you kind of refer to this kind of later on in the semester as we get, a lot more into the programming. And so, let's say that you're working on a homework assignment or we're doing an activity in class, and and you're thinking, oh, how do we update a value in a matrix using update notation? Then that's going to be here for you. And so, definitely keep these lecture notes on hand. Download them to your computer so that you can refer to them later, because it's I want this to be a resource for you guys. Okay. Actually, it is the very next slide. I thought there was actually one more between this, but if you wanted to manipulate an entry in the matrix using using the update notation, you can do exactly that. Okay, and so all the techniques that we learned before about manipulating variables and using them in equations, all that applies to matrix entries as well. Okay, and in particular, we're going to do stuff like this a lot, where we update or we modify specific entries in the matrix. And so, let's say that we only want to modify the 1, 1 entry in the matrix. And so we can say that the zeros matrix example in the first row in the first column is the old value of that entry plus 47. Okay. And so if you remember from the previous page, when we first defined this matrix, the initial or the old value of that entry is going to be 1. And so the new variable, that's the new value in this matrix that's going to be stored here is 1 plus 47, which is 48. Okay, and so after this line of code where we update just that one entry in the top left, then our matrix is going to look like this. And so we have 48, 1, 1, 9, 9, 9, and then 2, 4, 6. Okay, where in this case we've only updated the entry in the top left using this line of code right here. Okay. So this is going to be really useful because a lot of the algorithms that we're going to have is we're going to be building up these matrices kind of slow, little bit by little bit, and so in order to have an update notation like this is going to be really, really useful. Okay. All right. Any questions on this? Okay. All right, and so now let's talk about solving linear equations, right? And so like we talked about before, the one thing that a computer can really do is solve a linear system of equations. So they're really good at linear algebra. And so, it'd be really nice to have, ways that we can form linear systems of equations for computers. And the way we do that is to make use of the matrix form of a set of equations, right? And so let's consider this system right here, right? And so we have a system of 3 equations, and we have 3 unknowns, right? So our 3 unknowns are x1, x2, and x3. And so we can put this in matrix form by basically just lifting out the coefficients in front of the terms, right? And so, if we form a matrix system of x1, x2, x3, we can see from the first equation that we have coefficients of 3, 5, and 7, okay? So we have 3, 5, and 7, right? And so that goes into the first row of the matrix. In the second row of the matrix, we have x1 plus 9x3, right? No x2 here. And so the coefficients we have for that are 1 for x1, 0 for x2, and 9 for x3, okay? And in the last equation, we have x2 minus 3x1 is equal to 6, right? And so we can see here that we have a coefficient of minus 3 in front of x1, and so that goes right here, okay? We have a coefficient of 1 in front of x2, and so that goes there. And then x3 doesn't show up in this equation, so we have 0. Okay. And then the right-hand side of the system is going to be 0, 3, and 6. Okay. All right. And so now that we have this system of equation in matrix form, we're ready to actually solve this within MATLAB, right? And so the way we do that is we have to create variables that hold this matrix right here and hold this vector. Right? And so you can see here that I've created a variable called left-hand side matrix. And so I know I used the shorthand code for this, but it had to all fit in one slide. And so, I just had to write it all in one line, which is fine in this case, because we know all the entries in the matrix beforehand. And so, we can make use of that shorthand notation. So you can see here, I've constructed this matrix of 3, 5, 7, semicolon, 1, 0, 9, semicolon, minus 3, 1, 0. And then our right-hand side vector is 0, semicolon, 3, semicolon, 6. Okay. And so we've taken this linear, this set of equations, we've converted to matrix form, and then we've input their values into the code. Okay. And so to actually solve this operation right here, we're going to make use of a special MATLAB operator called backslash. Okay. Have you guys used backslash in MATLAB before in your previous classes?
No, not really.
All right, good. That's good.
Nope, I haven't.
All right, that's good. Yeah, no, it's something new for everyone. So it's really useful actually. So it's one of the most useful things in MATLAB because solving linear systems is a very common thing in programming. And so, if you have two variables here where you define the matrix and the vector, you can find their linear solution by just doing this backslash. Okay, and so you can say that your x solution here, x1, x2, x3, is going to be equal to your matrix backslash right hand side vector. Okay, and so this is going to return a 3x1 vector that's going to have the solutions for x1, x2, x3. Okay, and so they're basically MATLAB is going to perform all the linear algebra for you underneath the hood. Okay. All right, and so this is all well and good, but for a 3x3 system like this, it might seem a little bit more trouble than it's worth, right? And so for a 3x3 system like this, you can say that hey, it's 3 equations, it's not that bad. I can solve this by hand. I don't have to go through the trouble of opening up MATLAB, coding it in MATLAB, and running the code, right? But we're going to run into systems in this class which are, like I showed you before. Our linear systems are going to be like 100,000 variables, 100,000 unknowns, and 100,000 equations, right? And that's something actually on the lighter side. And so you have these ginormous systems of equations, right? That I won't say it's impossible. There's probably some Guinness Book of World Records out there or something of someone solving 100,000 by 100,000 system. But most people have better things to do with their time than solving a gigantic linear system. And so for the types of systems that we're going to be doing in this class, having a MATLAB code to do it for you is really useful, because this is just not practical, not feasible to do by hand. Okay. Any questions on this? Okay. All right, and so that's that's kind of the basics of MATLAB, right? And so that's defining variables, manipulating variables, using them for linear algebra, right? So now let's start talking about some more advanced programming concepts, right? And so now we're actually going to use some actual programming constructs in our code, to make it more sophisticated and more and able to handle more complex situations, right? And so the first type of programming construct that we're going to go over are conditional statements, right? And so in other words, you probably know them as if statements, okay? And so if statements are great because sometimes when we write a program, we want the program to do, we want it to take certain actions if certain conditions are met, but we want it to do something else if certain other conditions are met, okay? And a lot of times when we're writing the code, we don't know which way it's going to go. It's going to go one way or the other, depending on how the data shapes up or how, the rest of the program is going, right? And so we can give our program that flexibility by using if statements, right? And the syntax for the if statement is fairly simple, right? And so you're going to use the keyword if, right? And so when you type if into a MATLAB console, it's going to light up blue, right? And so that tells you that it's a special character or a special command, right? After the if, you're going to write parentheses, okay? And then inside the parentheses, you're going to give what I like to call a check condition, right? And so a check condition is basically something that can either return true, right? It can return true if it's true, or false, okay? Right? And so it's just true or false, right? And so it's something that can either be, have a binary condition. And so if the check condition returns true, or in other words, what we check for is correct, then we enter the body of the if statement, and then we perform, the work that we have here, right? And so this literally reads like a sentence. And so, we can say that if this check condition is true, then we're going to perform the work, if true. Okay. All right. And so another word for the check condition that you might have heard in a previous class is called Boolean, right? And so Boolean, I think, is just a fancy programming word for something that can just be true or false or binary, basically. Okay. But that's just some trivia. You don't really need to know that. Okay. All right. But if the check condition returns false, then what the program does is that it kind of just skips over everything in the body of the if statement, right? And so if this is false, then we don't do any of the work here at all, right? All right, so here's a couple, really simple examples that kind of show it to you in action, right? And so let's say that we define a variable, And so we define a variable called needs connection, and we set it equal to 3. Okay. And then we do an if statement, and so we check to see, if this variable has a value less than 5, then we're going to set its value equal to 5, right? And so that's what these two lines of codes do. Okay. And so let's run through this code to see, if that's true or not, right? And so we have a variable here that sets the variable equal to the value equal to 3. Okay. We check the condition, right? And so we check to see, if this variable here, which has a value of 3, is less than 5, which it is, right? So 3 is less than 5. Then what we're going to do is we're going to enter the body of the loop, and then the new value of this variable is going to be set to 5, right? And so after this loop, our variable here needs correction is going to have a value of 5. Okay. And so that's a case for when the check condition returns true. If the check condition returns false, then we just skip over this all this line here to begin with, right? And so you can see here that we have almost the exact same lines of code, except now our needs correction variable has a value of 9. Okay. And so if we check the if statement here, so we check to see if 9 is less than 5, which is not true, right? So 9 is not less than 5. And so we're going to skip everything inside the for loop here, which is just a single line. And we can say that needs correction is equal to 9, right? And so we skip over the if statement, and our variable here retains its same value as before, which is 9. Okay. All right. Any questions on this? Okay. All right, so now let's talk about else if, right? And so else if is kind of an addition to the if statement, and it allows us to check for kind of multiple conditions and do kind of one thing or the other, right? And so, in other words, you can kind of almost think of this as like a backup plan if the first conditional fails, right? And so the syntax for the else if is, something that looks like this, right? And again, it really helps to kind of read this as kind of like a sentence, right? And so the first thing that MATLAB is going to check is condition 1, right? So that's kind of our initial if statement. And so if that's true, right? If condition 1 returns true here, then we're going to run the function do this work, right? And then we're going to ignore everything else in the if statement, okay? But if condition 1 is false, and then the program checks if condition 2 is true, then we run this this line of code right here, okay? All right. And so what happens if both are true, right? And so if both condition 1 and condition 2 are true, which one do we do, right? Because it kind of seems like we're checking both right here. But because of the syntax that we use, where we use else here, right? If condition 1 is true, then we're going to do this work right here and ignore everything else, okay? And so I think that's another common pitfall people have, is that when they're using else if statements, then they think that if both condition 1 and condition 2 are true, then we're going to run both the bodies of these if statements, but that's not true at all, okay? And so if condition 1 is true, then basically the program is happy, and we can say that it's going to do this work here, and then after that it's going to exit the if statement, right? And so you can think of it as like the program check to see is condition 1 true? All right, let's do it. And then the program's like they don't pay me enough to stick around to check other conditions, okay? And so basically, as soon as the program finds a true statement, then it executes that code, and then it exits, from there. Okay. All right. So I have 3 examples here that kind of illustrate this in action, right? And so, in this first example here, we have a variable here that has a value of 11. Okay. First, we check to see if that value of that is less than 1. That's not true. Okay. And so then we check the other condition. So we say that else if needs correction is greater than 7. Which is true, okay? And so because of that, we're going to execute this line of code right here, where we set the value for needs correction equal to 7, okay? All right, so now we have a case where the first conditional is met, right? And so we're running the same code, but we're setting the value equal to 0, okay? And so since 0 is less than 1, then we're going to execute this line of code right here, again, because the first conditional is positive. but we're going to skip everything else. And so we're not even going to entertain the idea of coming down here, okay? All right, and so now finally, let's look at an example where both conditions are false, right? And so if we have a situation where we're setting the variable value equal to 3, we check to see if that's less than 1. That's not true, right? So 3 is greater than 1. Then we check to see if this variable has a value greater than 7, okay? Which again is not true because 3 is not less than 7, right? And so we're going to cross that out. And so none of the if statements actually triggered here, because the value of 3, made all of the if statements return false, okay? And so at the end of this code right here, we're going to have, the variable is going to have the same values it did before, which is 3. Okay. All right. Any questions on this? Okay. All right, and so the final thing that we'll talk about, in terms of conditionals is the else statement, right? And so the else statement, you can kind of think of it as, in case all other conditions fail, you still want your program to do something, you can stick it into the else statement, right? And so once again, we're going to check. First thing we're going to check to see is if the condition 1 is met. So if condition 1 is met, then we do this line of code here and we ignore everything else. Okay. But what happens if condition 2 is correct? So if condition 2 is correct or it returns true, and assuming condition 1 is false, we're going to cross that out. We're going to cross that out, and then the only thing we're going to do is that work. Okay. Right. And then finally we come to the else part of the if statement. Okay. And the else is there basically in order to make sure that the program still does something in the case that condition 1 and condition 2 return false. Okay. And so we can illustrate that example here, right? And so before, we saw that when we assign a value of 3, then both of these conditionals are not met, right? But lucky for this kid, there's an else statement here that can pick up the slack, right? And so after all the conditionals fail, we have this this else statement basically just to make sure that we can our program still does something. Okay. All right. Any questions on this? Okay. All right. So that's all the conditional stuff. And so we'll be making use of if statements throughout the class, right? The other thing that we're going to be making a lot of use for are loops, right? And so for loops are great. And so for loops allows us to basically repeat a set of programming statements as many times as we want. Okay. And so the general syntax for a for loop is given by the following. And so we start out with the keyword for, okay? And then we define what's called the loop index variable, right? And so the loop index variable, it has a name here. And so we're giving it a name index, okay? And then from there, you have to give both the starting and ending values of the of how you want it to loop, okay? And so, this is what you put here, okay? Right. Okay. All right. And so, this is just the kind of the general, the general syntax for a loop. Okay. So now let's talk about how we can actually use it. Right. So one popular way that we're going to use our loops in this class is to visit every single index variable or every single variable inside a vector or inside a matrix. Okay. And so let's consider this example here. We're creating a a vector of all zeros, right? And so that's what the zeros vector is here. And then we want to assign, a value to each member in the vector using a for loop, right? And so with this, you can see here that we have a loop index variable called index, right? And so that's going to go from 1 to 5. And then from there, we're going to assign variables. And so we can say that loop vector at index is equal to 2 times index, right? And so notice what I'm doing here. So notice that I'm doing I'm using the loop variable within the loop, right? Because what's happening underneath the hood is that, this index variable, it's actually counting up, right? And so, it's starting at the starting value, right? And so in this case, the starting value is 1. And then each time the loop iterates, it's going to increase by 1 each time, right? And so on the second iteration of the loop index variable is going to have a value of 2. On the third loop, it's going to have a value of 3, and so on and so forth until you reach 5. right? And so that's why we can use this notation here, because we know that index is actually climbing up, right? And so it's incrementing on itself. And so we can use that variable within our loop, to index or to basically visit all the entries in a vector. Okay. All right. Any questions on this? Okay. All right. And so what this slide does, it just kind of describes to you what's going on, right? And so remember the vector is going to be starting with all zeros, and then on each iteration of the for loop, the index variable is going to go up, and we're going to assign a different number to the vector, right? And so this is a really nice page right here. And so if you're having trouble visualizing how a loop is operating, then come back to this example, because I think it really helps to kind of write it all down, just so that just that you can kind of better understand what's going on in your program. All right. And so the craziness doesn't end there. And so just like a famous rapper Exhibit once said, if you like something, might as well put something in that something, right? And so in this case, we like our loops, and so we're going to put more loops inside our loops, right? And so this might seem kind of crazy, and so we're putting a for loop inside a for loop, to make sure that we loop, a ton of different times, right? And so you can see, and so whenever you have a nested for loop like this, the way that we talk about these loops is that we have an outer loop, right? And so this loop here is what's known as the outer one. And we also have an inner loop, which is going to loop on the inside. Okay. And so the way to kind of interpret this, because I think this is kind of an intimidating section of code right here, is to think about the hands on a clock, right? And so the way to kind of read this is that every time the outer index kind of goes up by 1, the inner loop is going to make a full rotation, right? And so think about the hands on a clock, right? And so think about the minutes hand and the seconds hand, right? In order for the minutes hand to move forward, one space, the seconds hand has to make a full rotation around the clock, right? And so you can think of the minutes hand here as like the outer index, and so the outer index is moving only after the seconds hand kind of makes one full rotation, okay? And so in order for the minutes hand to kind of make a full rotation, basically the seconds hand has to this is for something different. I think I did minutes and hours hand here, but in order for the minutes hand to make a full rotation around the clock, then the seconds hand has to rotate around 360 times, right? Because it's 60 times per hour. Or I'm sorry, I'm brain fart right now. So it has to rotate around 60 times, right? Basically, in order for the hand to go one full rotation. Okay. All right. Any questions on this? Okay. Right. So nested for loops we're actually going to be we're actually going to see those quite a bit in this class too, because if you go back to the previous slide, right, we can see that a regular for loop is great for visiting the entries in a vector, right? If you want to visit every entry in a matrix, the best way to do that is with a nested for loop, right? And so, let's say that we have a 3x5 matrix here, okay? And so in order to visit every entry in that matrix, we can have one loop that loops over the rows and another loop that loops over the columns, and then nest them inside each other just to make sure that we visit every single entry in the matrix, okay? And so you can see here that we have a nested for loop where we have a row index that's going to count from 1 to 3, okay? And the reason we go from 1 to 3 is because we have 3 rows in this matrix, okay? Then we have a column index that goes from 1 to 5. And so we have, and the reason we have 5 is because we have 5 columns in this matrix, okay? And then we're going to visit every single matrix, every single entry in that matrix using this nested for loop, right? And so we have a row index and a column index, and we're going to set that equals a count, which is a counter variable, right? And so the way to kind of read this for loop is that, it's basically building up the matrix kind of row by row, right? And so since the row index is the outer loop, we can say that we're not going to go on to the next row until we visit every single entry in that first row, right? And so we're going to visit basically all 5 entries, just like that, okay? And then after we visit all 5 entries, then we're going to move on to the next row. Okay, we visit all 5 entries, and then we move on to the next row. Okay. All right. And so, that's a convenient way to visit every entry in a matrix. Okay. Yeah. So the question in the chat is, what is the count? What is the count variable for? And so, the counter variable here is to basically have a way for you to have counts that that you can keep track of in the loop, right? Because normally, when we have a single loop, we have a single loop like this, right? We only have one index variable, right? And so we can have that index variable, we can use this index variable because we can count on it counting up from 1 to 5, in just one loop. But when you have a nested for loop like this, it's you're going to be looping over the rows and then looping over the columns, and then it's going to all reset and things like that. And so in a case where you want to count basically how many iterations that you make on the loop overall, you can have a counter variable like this. Okay. And so what I'm doing here is I'm setting a variable here, setting equal to 1. And so it's going to start at 1. And then each time that we iterate on the loop, I'm going to increment or update this this value by 1. Okay, so I'm going to say that count is equal to count plus 1, right? And then I'm going to use that variable here, to assign entries in a matrix, right? And so whenever you have nested for loops like this, or you kind of have, multiple things going on in a loop at the same time, it can really help to have a counter variable here, where you can kind of control how this variable, increments, right? And so here I have a very basic kind of counter variable where it kind of only increments by 1 each time. But I think in the examples later on in the class, you can see that this might increment by 2 or by 3, okay? And you have much more control over it, okay? And so this is really useful, because for a nested for loop, it's going to reset, it's going to iterate a lot of different times. And so if you want to keep track of how many loop iterations that you've done, then you can use a counter variable like this, okay? And in particular for this example, what we're doing is we're using that count variable to assign entries in the matrix, right? And so basically, the way to kind of interpret this code is that, count is going to start at 1, and you can see here that we're setting count, we're setting that value in for the, the first entry in the matrix, which is right here, okay? And then after this loop iterates, it's going to update by 1, and so now it's going to have a value of 2, okay? Because we're visiting a second column because the inner loop here is iterating, okay? Then we're going to have a value of 3. Then a value of 4, then a value of 5, right? Because each time this loops, the counter variable is going to be updating, okay? And then finally, we're going to move on to the next row, okay? And so if you look at the outputs for this this code, you can see here that it's 1, 2, 3, 4, 5, right? And then we go to the next row. This goes 6, 7, 8, 9, 10, and the next row, which is 11, 12, 13, 14, 15, right? And this is made possible by the counter variable that we're using, in the previous on the previous slide. Okay, and then finally, the last line of code that I'll show you is to put an if statement inside a for loop, right? And so this is really useful because there might be cases where you want the code.
Professor?
Oh yeah, what's up?
Sorry, I had a quick question. My mic wasn't working. Can you go back to that previous slide?
Yeah.
Sorry, the previous. So, the count. You can change the number in terms of like what number it is, right? So that number, so like count equals 1, you're just assigning 1 to that row and column. So if I was to do like count like 5, then on column 1, row 1, it'd be 5.
Yep, exactly. Yep. And so I started at 1 here just because it's because I wanted to have this kind of output right here where I go 1, 2, 3, 4, 5. But you can just as easily assign this count variable to start at 5, right? And so if you start this at 5, that's just going to change where you start, right? And so if you have 5 right there, then instead of starting at 1 here, you're going to have 5. And then assuming we keep everything else in the code the same, where we update the count variable we increment it by 1 each iteration. We're going to go 5, 6, 7, 8, 9, 10, and so on and so forth. But yeah, but depending on the application, you can start that variable at whatever value that you want. Okay. And you can change how it updates too. And so let's say that you want to count by 2s, right? And so you can start count at 2. And let's say that you want to count up by 2 each time the loop iterates. And so you can say that instead of count is equal to count plus 1, we can say that count is equal to count plus 2. Okay. And then we can say, and then from there you can say that this is going to be 2. And then since we're incrementing by 2, we can do 2, 4, 6, 8, 10, and so on and so on and so forth. Yeah. Yeah. So so that count variable is arbitrary, and you'll see different applications for count throughout the class. But I wanted to give you an example here of of how you can define basically a separate variable, and then you can update that independently of the loop indices. Because I think when people first start doing this, they kind of get stuck in using just the loop indices here. And we do use them, right? And so we use the indices here to indicate the locations of the matrix that we want to update. But you can keep another variable kind of separate from that and then update that independently, depending on however you want. Yeah. So it's going to depend on the application. Okay. And so the last thing I want to cover today is using if statements within for loops. And so this is really useful because this can be used to basically have the loop do something different depending on what index that you're looking at, right? And so here I'm making an if statement where I have this vector that's 20 entries long, right? And so I want to visit every entry in that vector, right? And so I'm having a loop index that goes from 1 to 20. And then depending on if that index is an even number or not, then I want to do something different, right? And so I'm using a special function in MATLAB here called mod, where mod all it does is basically performs division. Mod performs division between these two numbers and returns you the remainder, okay? And so if that remainder is 0, because we're basically taking a number, dividing it by 2, and so if that remainder is 0, then we know that we have an even number, right? And so if we have an even number, then we can assign we can perform an operation like this. If not, then we do nothing, and so the entries are 0. And so you can see here from the output that all the odd number entries here are zeros, because we're basically telling the program that if you find an odd number index, then just leave it alone. And so only do stuff for the even indices. Okay. And so having if statements inside your for loops can be really useful, if you want MATLAB to do something different, depending on the application. Okay. And we'll use this a lot too, because in this class, what we're going to do is we're going to be setting up a lot of matrices, very big matrices. And often what we want to do is we want to do something different on the first row, and we want to do something different on the last row, and maybe some rows in between as well, right? Depending on where the boundary conditions are. And so using an if statement like this to do something different on those rows, is going to be really, really useful for that. Okay. All right. Any questions on this? Okay. All right, and so here I have a couple examples, and so unfortunately, we only have a couple minutes left in the class, and so I don't have time to go through these in detail, but I would definitely recommend that you read these examples here, read kind of my logic, and then read the solutions, and then just try to make sure that it makes sense that these solutions are that they are what they are. Okay, and so one suggestion that I always give people whenever whenever I give you kind of sample code like this or example code is to go through it with like a fine-tooth comb and say that does this make sense? Can I follow this code, and does it make sense to me that it's producing this output here, right? And so don't just kind of read this code and be like, oh yeah, I get it, kind of thing. Actually go through it kind of line by line to make sure that you can get the same output as B. Okay. All right, so here's the first example. So this is an example of a nested for loop with a counter variable, right? So this is kind of building off of that counter example that we had before. Okay. And example 2, this is an example of using an if statement within a for loop, right? And so in fact, it's an if else statement, right? And so this is a great example to use to see how to use an if statement within a for loop. Okay. All right. And so the very last thing, just because we have 1 minute left, is to show you the plotting function, right? And so MATLAB does plotting really well, and this is really useful for visualizing your data and checking your work. Okay. And the way to use it is just to basically use this this plot function right here. Okay. And the entries in the plot function, you have to give it a vector for the x-axis you have to give it a vector for the y-axis. And then what it basically does is it plots a scatter plot for you, for those two things, okay? And so here I have an example where, I'm plotting a function for you, okay? And so I'm basically just plotting a quadratic function. And I say x is a lin space from 0 to 5, and then y is going to be equal to x squared. And then, I'm going to make a plot of y and x, which is shown just like this, okay? So plotting is really useful. That we'll use a lot in this class as well. Okay. All right. Any final questions on this? Okay. I know that it was kind of a blitz, and so there was a ton of information today, and so I know that it's going to be hard to really retain everything on the first look through, but I did want to have a review of kind of all the essential skills that that I'm going to expect you to have in MATLAB. And so we're going to see a lot of this throughout the class, and we're going to do a lot of activities in class where where we're going to write programs together, and we're going to use a lot of conventions that we talked about today. And so definitely download these lecture slides, keep them on hand, because they're going to be useful to you, going forward in the class. Right? All right, so thank you everyone for tuning in today. Hope everyone enjoys the rest of their evening, and I will see everyone on Wednesday.
I had a quick question on the homework.
Sure.
So in terms of like the section where you had like the redacted parts,
Yeah.
is that supposed to like match, like I guess like in terms of like hypothetically the length of the redacted part, is that supposed to kind of like match? I know there's like different ways to write MATLAB code, but like in terms of like so I know for like part number 3B, where we have to like do all the redacted like the syntax that we're supposed to use, is supposed to like fit into like that redacted part, or could it be like longer? You get what I'm saying?
It can be longer.
Okay.
So the redacted parts, I basically just took a screenshot of my code and put a black box over it. And so, it's the exact length of the code that I wrote, but it can be longer as well. And so, the only thing that matters is that it produces the same output as, the same output as I have. So, yeah, feel free to go longer or shorter. It's just the length of the boxes it just happens to be the length that I use for the variable names that I used. Yeah.
Okay, got it. Thank you.
Yep.
For the homework, would it be a MATLAB file submission, or is it like a PDF composed of all the different syntaxes?
If you can put it all in one PDF, that would be the most helpful for me, because it saves me from opening up several files. But if you can't, then uploading each separate as a separate M file, that's fine too. Yeah.
Okay, thank you.
Yep.
All right, cool. Thanks again, Dr. Tran.
Yep, no problem. See you, Chris.
See ya.
Thanks. Take care. Jacob, did you have any other questions? Okay. All right. I'm going to sign off. So I'll see you next time.